Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to this course on Circular Economy for Sustainable Buildings. Today we will look at the concept of rainwater harvesting, its significance, importance, what are the types in which we can harvest rain, the methods used, and then how we can reuse the water efficiently, and a case study. So, what is rainwater harvesting? As the name suggests, rainwater harvesting involves collecting the rainwater from various places like rooftops or roads or pavements or any surfaces, sunshades and so on, and you have to store this rainwater for future use. So, this water which we collect from the rain, this has a lot of debris, leaf, organic matter, inorganic matter, etc. along with that, and therefore we have to filter this water so that we remove these organic and inorganic debris and other contaminants before we start using it. After doing all this, what is the benefit of rainwater harvesting? Why should we even do it? First is that rainwater is a sustainable water source. What does that mean? It provides us with alternative water source for drinking, irrigation and other non-potable uses. So, we are not relying only on municipal water supply for our water use requirement, but we also have an alternate source which is the rainwater. Second is, if we don't collect this rainwater, there could be a risk of flood happening, and therefore rainwater harvesting helps us in flood mitigation because it reduces the runoff from the surfaces, and that helps us in controlling the flood. Third is, because it is an alternate source of water supply, the pressure on the municipal system will get dramatically reduced because you are no longer relying on municipal water waste for your 100% water use. Then let's see what is the need for rainwater harvesting. First and foremost is uneven rainfall distribution. What do you mean by that? See, if you see the daily mean rainfall graph that I have shown here, say for between the month of June to September, the rainy season for the country, if you see this has a lot of fluctuations. So, there are certain days of the month where there are peaks and certain days where there are very less rainfall. So, these peaks can even reach up to 14 or 16 millimeter, and it can dip even less than 2 millimeter. Say late September, if you see, this is less than 2 millimeters, whereas this can peak even up to 14 in the month of June or sometime even in late July. And harvesting rainwater during peak rainfall period will ensure that we have water available during the other lean period or drier phases. Second is the declining normal rainfall trends. So, there is a decline in rainfall trends. So, the trend of rainfall is changing a lot. So, you see this red line here, I will change the color here so that we can, if you see the red line, it shows that there is a gradual decline, and this red line is approximately around, see this is what I mean. So, this red line shows that there is a gradual decline and it stays around 6 to 8 millimeters in July or August, but it starts decreasing post mid-December. So, this indicates that we have to store rainwater definitely. And the third reason is that there is a rising demand of water. So, there is rise in water demand because of urbanization, and because there are more people coming into cities. We definitely need more water, and rainwater can double up as a source of water, so that we don't depend too much either on the municipal supply or on the groundwater, which is again getting depleted. And by storing this, what happens? We can mitigate not only floods but also drought. So, when there are spikes of rainfall, and if we are able to save that water, we will be able to mitigate flood, and using this saved water during the lean period will help us to mitigate the drought also. Let us see the different types of rainwater harvesting system. First, we will see the water butt. So, this is the most basic and simplest form of harvesting rainwater, and this is because of a humble garden water butt. What happens in this is, the rainwater that falls on the terrace, here there is a gutter. The gutter looks like this. If this is the slope of the roof, you have a gutter like this. So, when rain falls like this, the water gets collected and it goes like this through the gutter. So, there is a gutter which collects this water for it to flow, and then you have a container below. That's it. There is a container and there is a drain pipe which collects actually there will be a small slope like this of the gutter, which is a very mild slope, so that the rainwater that falls quickly flows through the gutter to the downwater pipe, and it gets collected in the water butt. So, the water that is collected like this can be used for, say, gardening, or it can also, you can, if the roof is very clean, then you can even use it for potable purposes. You can also pair this with a filter, and what happens because of that is, the water that is collected, that becomes of a much better quality. So, you can have improved quality of water. The second type is the direct pump submersible type. Again, this is a more common type of professional rainwater harvesting system, and this is primarily used in domestic areas only, domestic segments only, and it is very easy to install this. What happens here is, a pump is also installed underground, and then the harvested water is simply pumped directly to various appliances like the closet, wherever you want to use this rainwater. So, if you want to use this rainwater specifically for flushing, then as I told you, you have a gutter with a slight slope, rainwater falls on the terrace, the gutter collects the rainwater and through a down pipe it flows, and then here there is a underground tank, and in this underground tank there is a submersible pump, and that gets connected to any part of the building to which rainwater can be supplied. Of course, you should have multiple filtering system to remove the debris and dust also. So, if this tank gets into the danger of becoming dry, then a small amount of main water is also fed into it to maintain the supply. So, this can be used even for small commercial properties, but they have to be very small, because such system can tend to be a dual pump arrangement system also, but it has to be for primarily domestic, otherwise very small commercial properties. Then we have the direct pump. Then we have the direct pump suction system. So, this system will be slightly different in the sense that the pump is not inside the tank, but you have control on using this pump because it is placed outside the tank or in the house. So, this unit will also deal with the backup from the main water supply. So, there is no need to send the main water down to the tank. Then the next one is the indirect gravity system. So, this type of system will differ because the harvested water is first pumped into a high level tank, which is called as the header tank. So, the water goes to the header tank and then allowed to supply the outlet by gravity alone. So, you collect the rainwater, take it through a down pipe, through a system of filters, collect it, have a pump it back to the overhead tank, and from this overhead tank you supply this to the rest of the building. Now, the main water can also be fed with the header tank. So, this tank can double up as the water into which rainwater comes or into which the main supply also comes. Then we have the indirect pumped system. So, what happens in this is similar to the previous one, which is indirect gravity, except that the internal tank can be at any level of the building. It does not have to rely necessarily on gravity to supply the outlet. So, instead what happens, there is a booster pump set that is also used to provide a pressurized supply. This system has the benefit of feeding the mains backwater pipe to the underground tank, and at the same time it gives you greater flexibility because the booster pump can be made based on what flow and pressure your building requires. Then there is gravity only kind of a system, where what happens is, sometimes it may not be possible for you to have a system that functions purely through gravity, and therefore sometimes you have a situation where you could probably use only gravity as a system, and this requires no pumping, and therefore there is absolutely no need for any extra energy. In this arrangement, rainwater is collected from the roof, which has the gutter above, and then it should also have a filtration system, as I have been telling in all the cases, and then you have a collection tank, which are in turn above all the outlets. So, your inlet is here and these are your outlets. So, your tank is above, and what happens is, from here, because of gravity, the water is taken down to all the flush or washing machine and things like that. A much simpler and a rudimentary system can be say you have a sunshade, you design a stronger sunshade and have small water tanks in this, and you have a larger water tank which will supply the water here. And what happens, suppose you have a WC here, this tank can be connected to the flush. So, some a derivative of that is what I am saying, gravity only system. Then you have rainwater systems which are based on certain methods. So, first is the roof water rainwater harvesting system. So, how does it work? In this, what happens is, water is collected directly from the roof and it is connected into storage tank, which could be underground reservoirs, through gutters, filters and pipes. Mandatorily filtration has to happen because this water comes from the terrace and it could carry with it a number of debris, leaves, plastic and things like that, and therefore it has to be filtered before you take it to the storage system. And then there is the surface runoff harvesting. So, the first one is from the roof, whereas surface runoff harvesting means it collects the runoff from road, street, agriculture land and it is brought to the ponds or very large catchment areas which could be like reservoirs or storage tanks. The issue with it is you need a large infrastructure and some filtration also, because that water should not bring along with it too many pollutants. And then the third is the infiltration well and recharge pits. Here what happens is you direct the water into recharge pits or underground aquifers, either through wells or pits. Easiest in villages, what they would do is, if you have a well, what they would do is they would let the rainwater from the terrace fall into the well or get into the well even through piping. So, the benefit of this is it will keep replenishing your groundwater level and it will ensure you long term water security. So, the well and the underground aquifer will get recharged every time you do this. Then how do we reuse this rainwater? So, the ways we can efficiently use this rainwater is, first is we can use it for domestic purpose. Domestic purpose means what happens is you have to first and foremost filter this water properly. And this rainwater can be used for cooking, cleaning and even drinking. See, if you go to any village or small town even today, like it happens in my village. In my village, they collect this rainwater in large, that blue color plastic tanks, huge plastic tanks. What they do is, before the rainy season, they clear the roof, clean it completely and they do not catch the first rainwater. When it rains first, it takes away with it all the mud and the dust which could not be cleaned manually. From the second rain onwards, a muslin cloth is tied to the mouth of the large blue water tanks, and the tanks are placed one next to the other and rainwater is collected. Once rainwater is collected, they close it and keep it and use it literally like ghee, clarified butter, little by little. Actually, rainwater is very tasty. You can even try it when it rains, by keeping some vessels in your terrace and collecting and seeing how tasty it is. So, it can be used for drinking, provided you are sure that it does not contain contaminants, it does not contain the dissolved solids when it falls into your container. So, you should be sure about what is the weather, atmosphere, climate and air quality of your place before you collect it for drinking purpose. Second is it can be used for agriculture purpose, because you can have high quality of water. Rainwater is one of the purest form of water. So you can get very high quality water, and by using this you can reduce the strain on your underground aquifer. Third is it can also be used for industrial purposes, where it can be used for cooling, cleaning and other industrial purposes. So the best way to use these is that first you should filter it properly. This is very important. I would say leave out the first rainwater. Don't collect the first rainwater. All the no suspended particles in the air which gets dissolved in this water and things like that, or the surface on which it falls, all of that gets washed away and you will subsequently get clean water. And to this you have to apply filtration to ensure that you remove whatever debris or leaf or any other solid contamination it has. Second is you should store it properly, because that is a problem. When you store rainwater, it could attract insects, especially mosquitoes. So you should store it properly and in a clean manner. And third is you should keep regularly testing this to ensure that it is safe for the purpose for which you have collected. Is it safe for drinking? You need to test it so that there is no algal moss formation or anything like that. What are the benefits of rainwater harvesting? First is it conserves water and therefore it aids in circular economy, because the resource is directly from nature and you are using less from the municipal supply. And because you are using rainwater, you can decrease your water bills. So it's an economic benefit. Third is it can lower the demand on fresh water sources or municipal corporation. So the entire process of treating the water before you get from the municipal corporation, the entire energy gets saved when you use localized rainwater. Fourth is it will slow erosion in dry environments. Yes. And fifth is it will reduce flooding in low lying areas. So the dual thing that will happen is it will reduce flooding and it will also reduce your drought, because you are using saved water. We will now see a case study where rainwater harvesting has been used and we will see what has happened. So we will take the example of South India University in Mangaluru. Because what happens is there was a lot of water scarcity and also there was a flooding challenge, typical of what is happening in today's urban scenario. And that has happened because of the urbanization, industrialization and infrastructure development, which has led to a sharp increase in water consumption, especially in Mangaluru. So simultaneously, such cities will face many challenges like temporary floods because of increased rainfall suddenly, which is not predicted, and this highlights the need for efficient water resource management. Under these circumstances, rainwater harvesting is a very good solution and it's an important solution. So, rooftop rainwater harvesting can be a very good solution to mitigate water scarcity and flooding. This study on South Indian University aims to integrate rainwater harvesting as an initiative to make its campus more green, self-sustainable and also to reduce the load or pressure on municipal water system by using rainwater harvesting. So what have they done? This campus is actually located in Mangal Gangotri, which is about 20 kilometers from Mangaluru, and it is on a site of about 350 acres. So you can imagine it's a large site, and this also has a tropical climate, and the average rainfall The average annual rainfall is about 3,800 millimeters, which is quite good considering that it is 350 acres. So, this area experiences moderate to heavy rainfall from say May to October. This campus has lots of other buildings such as administrative blocks and hostel blocks, academic buildings, staff quarter, gardens, typical of any institutional building. The main water supply is got from Netravati river, and that requires a lot of pumping, because of which cost increases, efficiency gets reduced and has lot of management issues also. So, what they have done is, this institution, they have used GIS tool to measure the rooftop area, and this is also cross verified with on-site visit. This data is collected from the water supply unit to understand what is the demand of water in each of the campus unit, academic campus unit or administrative unit or hostel block, science block and so on. Then the historical rainfall data from 2000 to 2014 comprising of 15 years is collected from nearby IMD stations to calculate monthly and yearly rainfall averages and also variations in rainfall. So, what they did was they collected samples from rooftop and tested those for the physical and chemical properties such as total dissolved solids or the pH of water and so on, and analyzed to determine how suitable it is for consumption or use. So, what they actually did was they conducted a preliminary survey. What they did was they looked at what is the demand, current demand of water along with the population of people in each of the blocks of the institution. And based on that, they estimated the water demand, monthly how much water is required and annually how much water is required. Parallelly, what they did was they collected information on rainfall and the rooftop area and runoff coefficient separately. Based on that, they were able to estimate how much water they could harvest every month and annually how much water they could harvest. And based on this, they estimated the water tank capacity and conducted the economic analysis. Now, they analyzed the rainfall pattern and they found that the rainfall was like, it was not even, it was fluctuating quite a bit, and here you can see that they had very less rainfall around 2002 and 2004, whereas in the year 2006 and 2010, 2013 they had more than average rainfall. This was the mean rainfall line, and during these years it was no high. So, this goes to reiterate the significance of rainfall because of changing rainfall patterns. Some years we have more rainfall, so we have to store it. Some years we have less rainfall, and in that time we can use this water, rainwater. So, here you can see monthly how the rainfall changes. We can see that April, May had very less water, whereas June, July, August was all right, and from September it starts to dwindle. So, this is the rainfall pattern, and you see the rainwater harvesting potential for each of the buildings in that campus was also assessed. It shows that the staff quarters, the boys hostel, the central library and science block, they had the maximum potential, whereas there were some other buildings such as bioscience block or auditorium building and so on, or MBA commerce, they had medium sized of potential, and there were some which had less potential. So, the calculations revealed that a lot of water can be harvested from rooftop runoff. For example, if the staff quarters had a large rooftop area, that alone could collect up to 12,671.8 meter cube of water per year. So, the potential of collecting water was very high from some of the buildings, as I have shown. The total annual potential for rooftop rainwater harvesting through some of these selected buildings on the campus came 1,13,679 meter cube. This much water they could collect. 1,13,679 meter cube of water could be collected. Of course, there was some seasonality of harvesting. The highest water collection could happen during the rainfall season, that is between June to August, and that alone contributed to about 70% of the total potential. During the non-monsoon months, they collected water, and this collected water during the monsoon season could get pitched in along with a little water from the Netravati river, which is the primary source of river. So, the water, that was the rainwater harvesting potential for selected storage tank, showed that they could collect water from different points, and these were stored in different tanks. And there was tank 7 which they could store a lot of water, up to nearly 30,000 meter cube of water, along with tank 3 and tank 2 amounting to approximately 17,000 to 16,000 meter cube of water. Also, the water quality was deemed suitable after doing all the tests. It was suitable for non-drinking uses like gardening, washing, cleaning, based on simple pre-filtration, like removing the sediments or leaves or paper and things like that. So, this study recommends that we should add more filters like gravel, sand or charcoal to ensure that we have good quality water. So, this is a real case study which is already a published work, as I have cited, which shows that rainwater can really pitch in to save us from flood as well as drought, and this is done based on quantitative analysis. So, I conclude by saying that rapid urbanization and also increasing water demand has led to groundwater depletion. And for this, rainwater harvesting is a great alternative source of water because it reduces our reliance on external source of water like the municipal supply or the underground bore wells. Also, there is a great economic dimension to it, as it can reduce our water bill and pumping cost and give us long-term financial savings. So, the payback period for rainwater harvesting system can be reasonable, especially if we are looking at water stressed regions. Also, collecting this rainwater can help us to manage the storm water, therefore preventing urban flooding, very important, and it can protect our soil from getting eroded and maintain a hydrological balance. The excess rainwater which you harvest can be recharged to the groundwater, and it can restore our aquifers. This is important for long-term water security in urban and rural areas. Very important aspect that can happen immediately is it will reduce our dependence on municipal water supply, and this will ensure that we have water available throughout the year, irrespective of whether it is a drought condition or a dry season. And then it will reduce over extraction of natural water bodies, over extraction of no underground aquifers. It can preserve our ecosystem and contribute to greener and more sustainable urban landscape. and the rainwater harvesting as a technique is suitable for any type of buildings which has either a large rooftop or a lot of a lot of potential for surface runoff. It could be administrative building, residential complexes, commercial complexes, name it, and it has the potential. So, today we saw rainwater harvesting as one step towards the circular economy. With this, we will stop today's class and continue with another topic in the next class. Thank you.